electricity and circuit. This is our chapter. This uh, complete this lecture will be will discuss about the electricity and circuits as much as possible. Okay. Uh, uh, without out of context, we want to go. Okay. Out of context, which means about the discussion of light, reflection, shadows. We are not going to discuss in this slide. In this slide will be complete about it. Complete about it. Clear? Electricity and circuits. Okay. Electric cell. So tell me about little information. How does electricity work? How does electricity work? And where are where is electricity being used? Being used. How does electricity work? And how to use electricity in our work? Whereas uh, a lot of people are using mm, this is circuit, this current, this electricity. First of all, we already know electricity, which means current. Current is electricity. Electricity is current. There are no difference. Okay, there is no difference between electricity and current. Whatever you want to apply words, current or electricity, both the meaning will be same. Meaning will be same. So I asked you question: how does electricity work? Where is electricity being used? Today we can see a lot of uses of electricity. Today we can assume importance of a current. Today you are at home. Bulb inside your room will glow up, will be glowing up. Fan will be rotating. All this happening because of electricity. Electricity is being provided throughout circuit of uh, between switch and bulb. We can't explain uses of all those electric devices, but we can understand through some more uses. As in our house, in our house, we can see electricity. Uses of electricity as a bulb, as a fan, as a motor. Okay, in a lot of devices are being used for electricity. Okay, whereas there is a connection of electricity with the light. Light is incomplete as we know. As far as we know, light is incomplete without electricity. Electricity will provide electricity to glow up a bulb. Okay. So there is a connection of electricity with the light. Clear? So at our home electricity is being used. Here, where does electricity come from? Where does? From a power station. From a power station. Where does electricity come from? From a power station. In our area, at our area, you would see places of a power station. So electricity is provided from power station of electricity. Okay, in your mind, would be coming from where? Would be coming from where is electricity provided? So it is a place where there is a what, a field, a special for electricity, that is known as power station. So from power station, electricity is provided at our area. Clear? If power stations provides us electricity, this helps us to continue working at night. However, the supply of electricity may fall away. In such situations, we use a we in our night working, if we can see uses of electricity. So my point is, electricity is used more at night. That's why this is able to provide current in night time. Okay. Through this help, we can use torches. We can anything that is possible to use. Okay. In day, in day, we don't use most of electricity, but in working we use. Clear? So this is a power station. Okay. From this, here we will see that chemical storage, transformer. From transformer, electricity is flowing, current is flowing. Like this will go. Okay. And here we see what, thin, thin no, thick, thicker wire, because at power station are more electricity. That's why thicker wire is used in such a situation, and we see thicker wire in that places, because it is for power station. This thicker wire will be able to provide uh, electricity. This will not so hot yearly. Whereas if we use thin wire, then thin wire will get burned, will get hot. That's why thin wire is not used where electricity is more. Electricity is more. Where electricity is more, then wire will be thicker. Wire will be thicker. Clear? Electric cell. What do you say, buddy? It is a one cell. We are going to talk about only one cell. Okay. First of all, let's understand about all that is possible to understand a about electricity. So, practically, first of all, understand. Let's understand. So, it is the electricity cell. So, we use we use word cell also in our physics subject, and also in where in biology subject. So, meaning of a cell in biology subject will be different as compared to meaning of a cell in our in physics subject. Is it clear? So here we are adding word electric with a shade. So now it is an electric shade. So say the like this. Okay. So it is metal cap. Metal cap. It is made by metal, and it is a shape in cap. That that's why it is said what a metal cap. Okay, that's why it is said metal cap. Clear? Whereas this is a disc metal. Mm. Because it is made by metal. So and it is a shape in disc in flat. So it is a disc metal. Clear? Now electrician has a two terminals. Electrician has a two terminals. One side will be no. Here is what to identify two terminals of electricity. How this side, this metal cap will indicate about the positive terminal, whereas this metal will indicate about negative terminal. We can't say that it is a what positive terminal. No, it is wrong to say. Okay, so this is an indicator to explain about the negative terminal. Clear? So this side is said what a negative terminal, and this metal cap will indicate a positive terminal. Positive terminal. Clear? About terminal, we understood. We saw uh, about we discussed about upper side of a shell and about lower side of a shell. Okay. Inside this is found what chemical storage. As we were discussing, electricity is provided. We are using electricity to blow up bulb, to rotate fan. We are using electricity. So this electricity is coming from power stations of electricity. So similar inside this electricity is found what chemical storage. Chemical storage. Now inside this shell is end. Chemical storage. Chemical storage is end. Is over. Chemical storage is over. Then this electrician will not work. Then this electrician will not work at any cost because chemical storage is over. That's why. So chemical storage is what this provides electricity. This provides electricity. So to cover chemical storage, we need to get charge this electricity. If there is an option to get charge this electricity, then uh, we can we can bring what we can take uh, chemical storage. Okay, clear. So work of chemical storage is to provide electricity. Yeah. Now can we write definition of this? What is that we are which we are already we are a discussion about an cell electric cell. It's a time to write in a written form about the definition of electricity. Clear? Uh, it has two terminals. It has two terminals, positive terminal, negative terminal. Clear? Metal cap of electric shell is indication indication of positive terminal. Flat metal of electric cell is indication of yeah negative terminal. Negative terminal. Got it? So current is provided. Current is provided from chemical storage provides. Chemical storage provides current from inside it. Inside it. So about chemical storage we wrote, whereas terminals, about the terminals we discussed. Then positive terminal, negative. It is one. It is one cell. Okay, it is one cell. That's why. That's why it has less power. Electric cell is used. Electric cell is used in normal devices. In normal devices. Okay, electric cell is used in normal devices. I think now we are clear. What else? One thing. What? When chemical storage is over inside it, then it will stop to work continue. Okay, clear? When inside it chemical storage is over, then it will stop. It will stop to work continue. We can get charge charge this what this is it to produce to produce to produce to produce electric chemical. Chemical store. Clear? Chemical store. That's it. Now it's a time to understand about filament and bulb. Filament and bulb. Uh, Filament and bulb. Both are together. Both are together. So it will be better to understand about filament bulb together. Okay. Filament is seen inside the bulb. Uh, so this is bulb. Be clear. This is bulb. This is bulb. Here wire is connected with this, and also here wire is connected. So two wire, two wires are connected with this. So it is indicating about the two terminals, positive terminal and negative terminal. Clear? Now let's understand about all these factors. This curved wire is what? What is this curved wire? Curved wire. Curved wire. So it is a filament. It is a filament. Curved wire is a description about filament. Clear? About filament. So I hope you got it. This curved wire is seen inside the bulb is a definition of a filament. Inside this is a found gas, but I don't know clear. Clear? Bulb will glow up when light throughout this filament will be provided. Then this curve will glow. This curve will emit light. Clear? I hope we are clear. So current is flowing. Current is going on throughout the wire like this. Then we'll go uh, to pass the filament. Now like this, and now filament will work to glow the bulb. So this filament will emit the light. Clear? Then will pass through this. Then like this. Clear? Like this is how the bulb. This is how bulb glow up. Bulb glows up. Glow up. We saw work of filament. What else? What else? Let's write it. Did you know? This is a bulb. Okay. As we discovered, as we this is bulb. These are this bulb has two terminals. One side is what positive terminal, second side is negative terminal. This negative terminal is these terminals are connected with wire to connect with electric device. So this is filament. Filament is what? Filament can stop to glow up a bulb. Then filament will be found broken. When filament will be broken, then if a filament is not well, then bulb will not glow up. Clear? So when we listen bulb fuse, then which that means uh, wire, curved wire is broken. Curved wire is broken inside the bulb. That's why we name the bulb what fuse bulb. This was very interesting one because we listen fuse bulb. So it happens when broken, when filament is found broken inside the bulb, then we say what fuse bulb. Clear? Uh, let's write it. Bulb. Bulb has two turners. Two turners. These two turners are connected are connected with the wires. Why am I saying wires, not wire? Because here we are talking about two wires. We are saying two wires. That's why. Clear? One for a negative terminal and one for a positive terminal. Clear? Inside it is found gas. Inside it is found can be seen. Inside it can be seen what? Inside it can be seen filament. Filament. Filament, which means curved wire. Curved wire. It is a necked wire. Throughout this filament passes the current. Then bulb glow up. Clear? Filament if filament is found is say broken inside the bulb, which means bulb is considered fuse bulb. Fuse bulb, which means bulb is considered fuse bulb. Clear? Filament, we already know filament is not well, then bulb will not well. It's simple. Okay. I hope about bulb and about filament we have discussed, we have written. Now let's understand about an electric circuit. An electric circuit, which means a rod, which explains a road, a line. Okay. So in the context of electricity, we are going to use the word circuit. So throughout this circuit, electricity will be provided. To blow up a bulb, you can say. This is just example. So to define about electric circuit, we should have at least 2-3 materials. First of all, electric device, uh, such as bulb, okay, and second, electricity device from which electricity will be provided. So this is a bulb. One second. This is a bulb. This is a filament, covered wire. This is what shell. This is shell. This is switch. This is the switch. So here we are within three materials. Already I said you, we should have at least two materials, three materials to define an electric circuit. So now this circle is defining circuit, a road, a path. Okay, clear? So to blow up this bulb, if wire is connected well, then this will work out. This bulb will blow up. Okay, we see what connection of wires is well, but still bulb is not glowing up because of filament is broken. That's why if filament is well and still bulb is not glowing up, so we can say there will be what broken wire. There will be something wrong with this circuit. So all things are well, then it will work out. Clear? This is electric switch. This is a battery differential. Otherwise, electric switch. This is a bulb. Clear? About bulb we discussed. We will come on the discussion of this electric switch. Let's understand also about it. Electric switch is used to as a switch. When switch is on position, then electric device will work out. But switch is on, switch position of a switch is on off position. In off position, then bulb will not glow. And it is made by what? It is made by plastic. Further in further discussion, we can understand about plastic that what electric switch is made by. So here, let's suppose that here we are looking at broken wire. You can see. Now will this bulb will work? No, because wire is broken. Because the wire is broken. That's why. That's why wire is broken. That's why bulb will not glow. So wire should be connected with another wire. With another wire. An electric circuit. This is a circuit to provide electric to provide electricity throughout the circuit. throughout the circuit. Clear? This is a circuit to provide electricity throughout the circuit. Clear? There, there should have at least two materials. At least two materials. So that to define to define it. Clear? Such as bulb, electric device, which will provide, which will provide current through wire. Okay, and wire, wire, wire to connect with the positive terminal of electric cell with the negative terminal to the bulb. Clear? Throughout this circuit, inside the bulb, throughout the circuit inside the bulb is a seal broken wire. So it is a description. It is a description of a fuse bulb. Of a fuse bulb. Clear? Bulb will not glow up. Bulb will not glow up. If a filament is well, if a filament is well, still bulb is not glowing up. Is not glowing up. There will be wrong with other connection, such as with the wire, with the wire, maybe 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 switch would be would be maybe switch would be in switch off, which explains broken wire. Okay. This was a discussion of an electric circuit in a written form. Let's try to understand about electric insulators. Electric switch. I hope we are clear. And we can write here. Uh, it is made by plastic material. Okay, plastic material. This electric switch helps us to protect from necked wire. Clear from necked wire. We can take help. This we can take help this to switch off or switch on. Clear? Clear? I hope we are clear. We are able. We feel safety. We feel safety to use this switch because it is made by electrical insulators. Electric insulators. Now it's a time to understand about electric conductors and insulators. We can understand here. Now, can you tell me about it? Electric conductors and insulators. At least some little information about it. Let's see discussion of this. One side is conductors, one side is insulators. What is the meaning of it? Look, conductors. Will conductors are able to connect with the electricity, with the current easily. Okay, but whereas insulators are not able to connect with the electricity, with the current. Okay. Because conductors are made by iron, copper, silver, aluminum. But whereas insulators are made by are what wool, what book, marker, plastic. All these are insulators that don't want to get attached with electricity. Okay, so we can say insulators are bad conductor for electricity, but whereas electric conductors are good conductor to get attached with electricity. That's why it is said what we put. Let's suppose one wire, one wire. is connected with the power station. Now, and other wire is connected also with the power station. Here we are looking what a gap. So here if we put what a rod, you can say a rod. Now this will work out. Uh, Electricity will follow throughout the iron. It helps to connect with the electricity. So it is a good conductor for electricity. Clear? So here, if we put place of this marker, then throughout this marker, electricity will not go because this is insulators. This don't want to get attached with electricity. That's why. So here, electricity will till here, and in this side, electricity will till here. Will stay till here. Clear? This electricity will not pass throughout this marker. Throughout this marker. Clear? Throughout this marker. Okay. So whatever are materials, those materials are not connecting with electricity. Those materials are bad conductors for electricity, for current. Those materials will define those materials are a description of electric insulators, and such as examples of insulators are what marker, book, door, plastic door, not iron door, uh, wall, house. All these are not mm, electric uh, conductors. All these are electric insulators. So we are talking about the conductors. So are we for electricity? Are we good conductor for electricity? Yes, of course. We are good conductor for electricity. We can electricity can attract our body. Okay. Electricity will attract when we touch the electricity, then electricity will come throughout our body. Our life can be loose. That's why it is said we should be aware uh, to experiment with electricity. We should not touch. It is said in a book we should not touch naked wire. Naked wire. We should not touch naked wire. So we are good conductor because inside our body is found water. Water is also good conductor. Okay. Inside our body is found what water. That's why we are conductor for electricity. Okay, we are not an insulator. And when we go to connect with electricity, then to live us from connecting with electricity, other third people will use to live connecting between a man and electricity. Third person will use insulators materials, so that person can go from away can go away from electricity. Electricity. Yeah. Here we can say we use our in our mind would be coming. Electric conductors compulsory are compulsory for electricity for current. But whereas also electric insulators are compulsory. Okay, are compulsory. For example, net wire we see what by covering plastic material by covering plastic material. So it was compulsory to cover by plastic material the wire. It was compulsory. So in some cases, uses of electric insulators are very compulsory. Also compulsory. Okay. Also compulsory. So here we can't say what insulators are waste. No. Work of insulators are nothing in any places. No. As much as we work uh, through help of conductors, whereas we use what insulators in electric working. Clear? Symbols of electric components. I hope that's right. Electric conductor. Those objects, those materials, those things, whatever, those materials, those materials which will allow, which will allow to pass the electricity to which will allow to pass the which will allow to pass the electricity which will allow to pass the electricity throughout the throughout the throughout the material throughout the material. Those materials which will allow to pass the electricity throughout the material. Clear? Uh, it attract it attract the current easily like magnet magnet. Okay, clear? It is enough to define it. We are we are good conductor. We are good conductor. Okay, conductor for it. Maybe because of inside our body is what inside our body is hot air. Okay, examples of electrical conductors are marker book, wall, house. It is clear. Whereas electrical insulators, it is enough. Further of this we can write we could have written, but that is enough. Electrical insulators. Electric insulators. Those things which allow, which don't allow, which won't allow, which won't allow to pass the electric, to pass the electric. It is said a bad conductor for current. This does not want to get attached with current. Okay. By covering plastic on wire on wire this wire is an example of insulators that is being that is used as a guard conductors. Example of electric insulators. Example of electric insulators are, this was wrong. These are not examples. These were not example of electric conductors. Okay. Here iron, copper, silver. This book, wall, house. What is it? Now symbols of electric components. Let's understand symbols of electric components. Now, whatever we would be discussing now, it is easy to understand. Symbols of electricity components. This is bulb. First of all, let's make a diagram of electrical what circuit. Like this. Clear? This is a circuit of electric. Clear? We are going to discuss about the symbols of the electric components. Here we see bulb. So symbol of bulb to represent is what? Is what? Is what? So first of all, symbol of electric cell. Let's understand. Symbol of electric cell. So one side is what? Positive terminal and one side is negative terminal. So this thin thin line will indicate symbol of electricity, symbol of a positive terminal of electricity. This is a positive terminal. Why? Positive terminal. Clear? So thicker line will indicate positive terminal, whereas shorter and thin. No. This is thin and long. Okay. Thicker and shorter will talk about negative terminal. Negative terminal like this. Negative terminal. Okay, clear? This was a symbol of electric, symbol of terminals of electric cell. Now electric bulb. Let's understand. Let's see symbol of electric bulb. Is it a symbol of electric bulb? Yeah. Whenever we look like this will indicate because this curved wire is indication of this curved wire is indication of electric is indication of filament of a bulb. So one side is wire, second side is a wire. Okay, this is a way to represent a symbol of electric device. Clear? Now we saw a symbol of a electric device. Second we saw symbol of electric bulb. Third is switch in off and on position. So here this is a switch, electric switch. Now this is in mode of on. Okay, this is in on position. This is on position. This is on position. What if uh, this is one wire, this is a second wire. This is one wire, this is the second wire. Okay, this is one wire and this is a second wire. Oh, second. So here we this is electric switch, and this electric switch is in on position. That's why it is said what this will indicate on switch on position. Clear? Whereas we see what broken wire like this. This is a symbol to represent what switch off. Okay, to represent switch off. This was a symbol to represent switch off. Wire. Symbol of a wire is what will this symbol of a wire to represent a wire. Okay, clear. So it is easy, very easy. By drawing a line, we can represent a wire. Clear. This was a symbol of a wire. About a battery. About battery, let's understand. About battery, let's try to understand. We already know, and we also discussed inside this lecture about battery. About battery. Battery has two terminals, negative terminal, positive terminal. Inside battery is on the chemical storage, and the battery has more power as compared to electric cell. Okay, and this is used in advanced devices. It was made to use in advanced devices. Okay, so here we also know what it is a collection of cells. It is a collection of cells. So here we are going to look symbol of a battery. So symbol of battery. Already we know this is a collection of cells. So this is what positive terminal of a cell, electric cell. This is a negative terminal. This is a negative terminal of an electric device. Similar, like this we'll see. So here, one side we are looking positive terminal, then second side we are looking negative terminal. One side is a negative terminal, second side is a positive terminal. One negative, positive, negative. So these are different. These are inseparable. That's why it will work out as a battery. Okay. So here there should be connection of these terminals in different way. For example, positive, such as positive, negative terminals. And this connection of more cells will make a battery. Clear? Such a combination of two or more cells will be named battery. Like this it can be understood. These are cells. One wire, positive terminal of this cell will be connected with the negative terminal of this electric cell, like this. This is wire. Okay. Similar, this positive terminal of this electric cell will be connected. This will be connected with the negative terminal of electric device, of electric cell. Similar like this. This is a combination. This is a right. This is a incorrect. This is a combination in correct way. In a correct way. Now let's understand about the heating effect of electric current, then electromagnets. That's it. Heating effect. When will wire be hit? When will wire be hit? Okay. Those definition will explain about heating effect of a wire, of electric current. Clear? So we are using wire. Wire will be more with connection of electric device, and with connection electric device that is coming electricity is coming from electric device. So wire is a shorter, then this will be possible to hit this wire, because because wire is shorter. Wire is shorter. This will become so hot in a few minutes, and high electricity is provided throughout the wire. Then, clear? So it will depend on length of wire, materials of wire, okay, it will depend on length material. High electricity will be provided throughout the thin wire with thin wire with a short wire. This will not work out. This will rather this will burn. Wire will turn into burning. Whereas it is compulsory to know that electricity is being provided high, then wire should be thicker and longer. Okay, a small devices we can use thin wire and short also short as much as needed. Okay, rating effect. This filament globes, this filament globes, and whereas if we touch this electric bulb after after growing up for few minutes, then we feel what hot bulb, warm bulb. So it happens because of electricity passed throughout the filament. That's why bulb is what uh, warm or okay. And this is why okay clear. This is why electricity is being provided throughout this wire. After few minutes, this after few minutes, if this is thin and uh, short, then this wire will turn into burn. After few minutes, we can touch to check wire is hot or not. Okay, hot or not. Clear? So why will hit when 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 high electricity is being provided throughout a wire, and wire is thin and short, then it will take less time to burn to hold the wire. Okay. This hit this is happening is known as hitting effect of electric current. Electromagnet. Electricity acts like a magnet. Electric current wanted to get attached with electric conductors. One side we can say it is acting like a magnet. Clear? Electromagnet. Magnet I hope we know. Magnet attracts iron devices. This will be near in front of this iron. Iron will get attached with this magnet. Whereas similar electromagnetic is in front of electric conductors. So when we touch both electric conductors and electricity, then electric will work faster. We can say electricity will work like a magnet. Magnet works faster to get attached with uh, this iron. This is how definition. This is how electricity act electricity acts like a magnet. I hope now we are clear. We are clear inside this electricity and circuit. We understood, we saw all this. Uh, we understood as much as possible. Okay, but our understanding of intensity from here till here was at high level. After this, our intensity of understanding will keep happening, keep up happening. So it was a simple. That's why. Already saw we had saw whatever information of a battery. That's why it was a simple. Heating effect. Heating effect can be defined with the electric circuit. Okay, electromagnet. Uh, we are adding a magnet word with the electricity, so it is explaining that magnet electricity works like a magnet. Okay,